When you look up at the night sky, you think you're looking at the universe, right? Wrong. You aren't looking at reality. You are looking at a ghost town. Most people believe that with powerful telescopes we can see all the way back to the beginning of time. They think light travels forever. That is fundamentally, completely wrong. Here's the part nobody tells you. Light is leaking out of our universe. It is bleeding out, vanishing. Right now, as you watch this video, thousands of galaxies have been wiped from our sky forever. They have moved so far away that their light will never reach Earth, not ever. You think space is a fixed box where things just move around. But space itself is stretching, and it's pulling the light with it, stretching it so hard that the light is actually falling out of the frame of reality. People say light is eternal, but that's just a label. It's an illusion. Sounds impossible? Let me show you. Try this right now. Close your eyes and imagine a thick black rubber canvas. Paint millions of glowing dots on it. This is our universe. Now grab the edges of that canvas and pull, stretch it hard. The dots move apart. But what about the light traveling between them? Space is physically growing the floor beneath the light. This is where your intuition completely fails. You think light will always reach its target, no matter how long it takes. A year, a billion years, it will get there. Wrong. Stop. Think about this. There is a point where space itself is stretching so violently fast that the speed of light simply loses the race. That light bleeds across the boundary of our universe, forever. But wait, physics says nothing is faster than light. All of science is built on this. So how is space breaking Einstein's supreme rule? Einstein gave us the ultimate rule, the speed of light, the cosmic speed limit. C equals 299,792 kilometers per second. Nothing in this universe can travel faster than this. No rocket, no particle. People say this is an unbreakable law, right? Wrong. There is a loophole, a massive cosmic cheat code, and the universe is using it every single second. Here's the part nobody tells you. Einstein's rule says nothing inside space can move faster than light, but he never said how fast space itself could stretch. Let me say that again because it will break your brain. Things in space cannot move faster than light, but space itself can do whatever it wants. It has no speed limit. Try this. Imagine you are at an airport. You are standing on a flat moving walkway. You have a physical running limit, say 10 kilometers per hour. That is your absolute max speed. You cannot run faster than that. But what if the walkway's motor is set to 100 kilometers per hour? Your legs are still only running at 10 kilometers per hour on the rubber belt. But to someone standing on the normal floor, you are zooming away at 110 kilometers per hour. You didn't break your personal speed limit. The ground just slid out from under you. Exactly. On the epic scale of the universe, this is exactly what is happening. Galaxies aren't actually traveling faster than light. Inside their local space, their speed is completely normal. But the dark, empty space between them is continuously being created, stretching. When we look at the deep universe, there is so much space between those galaxies that when it all stretches at once, their combined recession speed crosses the speed of light. Hubble's law proves this mathematically. V equals h0 times d. Velocity of expansion v equals Hubble's constant, h0, times distance, d. The further the galaxy, the more space there is to stretch, the faster it recedes. This is where your intuition completely fails. If a distant galaxy is moving away from us faster than light due to expanding space, what happens to the light it just fired at us? That light is trying its hardest to reach Earth, but the road, space, is growing longer faster than the light can run. It's like running full sprint on a treadmill that keeps getting faster and faster. So what happens to that exhausted light trapped in space? It gets trapped in time. Its energy starts bleeding out of reality. But physically, how does that actually happen? Let's look at a trick you've experienced in your everyday life. You have felt this cosmic phenomenon thousands of times in your life. You have literally heard it. People say physics is just complex math. Wrong. Physics hits your eardrums every single day. Think of a time you stood by a road. An ambulance was speeding toward you. The siren sounds high-pitched and sharp. Then, the exact second it passes you and drives away, the pitch drops. The sound becomes deep and slow, right? Exactly. It's called the Doppler effect. But here is a question. How does the ambulance driver hear that siren? To them, the pitch never changes. The siren is exactly the same. This is where your intuition completely fails. The sound didn't change. Your relationship to the sound changed. When the ambulance approaches, the sound waves get squished together, compressed. The frequency goes up. When it drives away, the waves get stretched out, elongated. The pitch drops. Now watch what this implies. Because sound and light are both waves. Zoom out from that street. Look up at the stars. If a galaxy is speeding toward us, its light waves get squished. Blue light has a short wavelength, so that galaxy would look blue. But when we pointed our telescopes at the sky, the galaxies weren't blue. They were stretching. Their light waves were elongated. They were turning red. This is called cosmological redshift. Z equals lambda emit, lambda obsedvi, minus lambda emit. But there is a massive catch here. This isn't the ordinary Doppler effect. The ambulance was moving through space. Galaxies are not. Here's the part nobody tells you. These galaxies aren't flying backward. The physical space between them is expanding, dragging those light waves with it. Space grabs the incoming light wave and stretches it continuously like a rubber band. And as a light wave stretches longer, its color turns red. But wait, if space just keeps endlessly stretching that wave, what happens? When you stretch a rubber band past its limit, it snaps. What happens to light when it crosses the limit? Light isn't the rubber band that will snap. This is where your intuition completely fails. People say light is just tiny glowing particles shooting through space. Wrong. Light in reality is a vibration of the electromagnetic field, a wave. Imagine you are floating in the middle of the ocean. Large waves come by, lifting you up and down. You observe these waves. Now think of a simple formula. Wavelength multiplied by frequency equals speed. C equals lambda times F. The speed of light, c, is fixed. So if the wavelength, lambda, grows, the frequency, f, must drop. The math is simple, but what is reality doing in the night sky? Here's the part nobody tells you. This ocean, the medium the waves are traveling through, is literally growing. Imagine the water itself is multiplying between the waves. When light first left a distant galaxy heading for us, its journey was millions of years long. That light held on to its energy tightly, like a coiled spring. It was blue or ultraviolet. But along the way, space continuously grew. It stretched, and it physically pulled that tight spring, the light wave, apart. Let me say that again because it will break your brain. The light wave is traveling at its fixed speed, c. But the very fabric of space it is walking on is expanding beneath its feet. So the distance from one end of the wave to the other gets longer, stretched. As the wavelength increases, the color changes. Blue to green, green to yellow, yellow to red. This is cosmological redshift. But wait, this isn't just a visual color change. Deep mechanics are at play here. There is a fundamental rule in quantum mechanics. E equals h times F. Energy, E, is directly tied to frequency, F. Planck's constant, h, is just a number. If light stretches, the wavelength gets longer, and the frequency drops. This formula dictates the wave's energy must drop. Exactly. As light travels its long journey, it gets redder and it loses actual physical energy. This energy loss isn't ordinary. It's not from friction. It didn't hit anything. Space is just growing, squeezing the life out of the light. Stop. Think about what this actually implies for your future. If space stretched at a uniform, steady rate, fine, light would eventually reach Earth, just a bit redder. But the universe isn't stretching at a uniform rate. It's stepping on the gas pedal. If light leaves a place where the space behind it is growing faster than it can run, what happens to it on that cosmic treadmill? This mysterious stretching of space was fine up to a limit. Scientists used to think the universe's expansion was slowing down, that gravity was pulling everything back together after the Big Bang. People say gravity is the ultimate pull. Wrong. The universe had a massive surprise hiding for us in 1998. There is another invisible force working in direct opposition to gravity: dark energy. This energy is baked into every cube of space. When space stretches, more space is created. More space means more dark energy. Here's the part nobody tells you about the Big Bang. It isn't just expanding, it is accelerating. Try this. Close your eyes and imagine a rubber band between your hands. You stretch it at a steady speed. But what if you pulled your hands apart faster and faster and faster? What happens to an ant walking on it? Let me say that again because it will break your brain. Light isn't traveling on an ordinary road anymore. It is running on a treadmill. But the treadmill belt is running in the opposite direction. And because of dark energy, every passing year, the belt spins faster. You might be thinking, light is running at the speed of light, c. Yes, light's speed is fixed. c equals 299,792 kilometers per second. But the treadmill's surface is compounding. When you add up thousands of light years of space between distant galaxies, the total stretching speed eventually beats the speed of light. When the distance d crosses a certain point, the recession velocity becomes greater than c, meaning at that distance, space is stretching backward faster than light is running forward. Now watch how this trick works. Light leaves that distant galaxy, trying desperately to reach Earth. But every year it takes one step forward and the ground pulls it 2 steps back. This is where your intuition completely fails. There is no physical wall stopping the light. The light is still moving forward in its own local space, but from our frame of reference, it is moving backward. When that light crosses that boundary, its wave is stretched so violently that its color, energy, and existence are pushed to the absolute extreme. So at this physical edge of space, where the speed of light loses the race, what do we actually see? Where are the borders of reality? When this cosmic stretching reaches its extreme point in our frame, we hit a limit, the edge of reality. People say the universe is infinite, right? Wrong. The universe might be infinite, but our observable universe, the part we can interact with, is bound by a strict, terrifying limit. Here's the part nobody tells you. There is a literal boundary where light is receding faster than. See, when you point your telescope at the sky, you are only looking inside a spherical bubble, a bubble with a 46.5 billion light-year radius. The border of this bubble is the, quote, particle horizon. Beyond it, reality is disconnected from you. This is where your intuition completely fails. You think if we just wait a little longer, the light from those distant galaxies will eventually reach us. After all, it's traveling through space, right? Wrong. Because the expansion is accelerating, thanks to dark energy, this horizon isn't bringing new galaxies into view. It is functionally shrinking in terms of what we can access. Let me say that again, because it will break your brain. Any galaxy that slips 1 millimeter outside this cosmic horizon today, the light it emits today will never reach Earth. Not in 1 billion years, not in 1 trillion years. For that light, the journey toward Earth literally becomes a journey backward relative to us. V rec equals c. The exact boundary where this recession velocity, v rec, matches light speed, c, is called the Hubble sphere. Photons emitted right now from just outside the Hubble sphere are physically dragged away from us by the expansion of space. Try this. Close your eyes and imagine a rubber band. A colony of ants is walking on it. You pull the rubber band faster than their tiny legs can run. The ants are moving forward physically, but compared to your hand, they are moving backward. This is exactly what is happening to light. But wait, this isn't sci-fi. This is happening in your sky tonight. If space grabs those incoming light waves at the horizon and endlessly stretches them, the wave grows infinitely long. When a wavelength stretches to infinity, its frequency drops to almost zero. And when frequency, F, hits zero, what does our energy formula, E equals H times F, say? Stop. Think about what this actually implies for your future. If space is acting as a massive energy leak, what happens to the light when it hits that limit? Where does the energy actually go? Hold on. If light's energy is constantly dropping, where is that energy going? The first law of thermodynamics says energy cannot be created or destroyed. People say energy is always conserved, right? Wrong. The biggest rule in the universe is breaking. This is where your intuition completely fails. As light stretches and turns redder, the photon's energy drops directly. You probably think this energy is converting into heat, or changing into some other hidden form of energy. Here's the part nobody tells you. That energy is just vanishing. It is bleeding out of the universe, gone. Let me say that again, because it will break your brain. When we look at light from distant galaxies that is billions of years old, most of its original energy has literally disappeared by the time it hits Earth. There was no friction on that journey, no collisions, just continuous expansion. And that expansion deleted the photon's actual energy. So what about Einstein and the first law of thermodynamics? Here is the trick. The law of energy conservation only applies to a closed, non-changing system. But the universe? It is a stretching, growing system where time symmetry, physics laws staying constant over time, does not apply globally. Because the background space is constantly changing, dark energy adding new volume, energy conservation simply isn't valid on a cosmic scale. Now watch how this trick works. You look at this tired light. Its frequency has dropped so low, its wavelength stretched so far that it approaches infinity. As the wave stretches endlessly, it leaves the visible spectrum. It becomes infrared, then microwaves, then radio waves, and finally, the frequency practically hits zero. Try this. Imagine a violin string. You stretch it continuously, infinitely. The pitch drops so low that eventually it stops making sound entirely. The string didn't break, it just stretched into total silence. Light does exactly this. Near the edge of the universe, it stretches and fades until it hovers on the boundary between existence and non-existence. Its entire energy leaks into the vacuum, zero. But wait, if galaxies at the horizon are sending us this bleeding, faded light, how many galaxies in our sky are dying this exact death right now? And when you look at a sky full of stars, what is actually left out there? Here's the part nobody tells you. When you look at the deepest images of the night sky, captured by James Webb and Hubble, those galaxies aren't actually there anymore. People say stars shine for billions of years. Wrong. You are looking at a dead scene, an illusion. This is where your intuition completely fails. Now watch how this trick works. There are an estimated 2 trillion galaxies in the observable universe, but roughly 94% of them have already crossed the horizon, where dark energy's expansion beats the speed of light c. Meaning, a light wave emitted by 94% of those galaxies today will never, ever reach Earth. Let me say that again, because it will break your brain. 94% of everything we can see is already gone. We are only seeing their ghosts. Light took billions of years to arrive. The image hitting our lens today was captured when they were still safely inside the horizon. Today, they are disconnected from our reality forever. Try this. Close your eyes and imagine a fireworks explosion. A rocket bursts in the sky. Millions of sparks fly outward. You are standing in the center. Suddenly, the air between you and the sparks expands so fast that the sparks can physically never return. They exploded, but you only receive a delayed flash of light, while in reality, the sparks are already tumbling in the dark outside your universe. These ghost galaxies are plastered across our night sky in the exact same way. And as time passes, that 94% will become 95%, 96%, and one day, 100%. Stop. Think about what this actually implies for your future. This isn't sci-fi. This is happening in your sky right now. If we built a light-speed spaceship today and flew toward those galaxies, we would never reach them, because the road is being built ahead of us faster than light can travel. Every single second, roughly 60,000 stars slip past our cosmic event horizon, becoming permanently unreachable. They are forever locked in a past we cannot touch, cannot change, cannot reach. And when the very last of those stars slips beyond the veil, what happens to the sky? Wait, if this expansion runs forever, what will tomorrow's sky look like? What will tomorrow's sky look like? Here's the part nobody tells you about the Big Bang. As the universe expands, its internal temperature drops. Every object is pushed apart, and the cosmos cools to a deadly freeze. People say we live in a universe full of light. Wrong. You are alive in a very temporary, glowing window, a final fire that is quickly burning out. This is where your intuition completely fails. Right now, you look up, the night is dark but filled with billions of shining stars. But trillions of years from now, dark energy will continue pulling the fabric of space apart, faster and faster. When all galaxies are pushed beyond the horizon, where recession velocity beats c, every galaxy will become an entirely isolated island. Let me say that again because it will break your brain. When future observers look for distant galaxies, the expansion of space will have redshifted the light so severely that it stretches, fades, and melts entirely into radio silence, bleeding out into the black void. Try this. Close your eyes and imagine a room with a single candle burning. You run away from that candle endlessly. The flame looks yellow, then red, and then no rays reach you at all. The light is bled off. On that day, trillions of years in the future, there will be no extragalactic stars in the sky. Only our local gravity-bound galaxies, the Milky Way and Andromeda, will remain, merged into one giant cluster, Milkdromeda. The rest of the observable universe will be completely empty, completely dark. This is called the Big Freeze. The sky will just be pitch black ink. Any future civilization that points a telescope at the sky will truly believe they are completely alone. The entire universe, empty. Stop. Think about what this actually implies for your future. This isn't a theory. It is the fixed destiny of our cosmos. The universe won't even leave them evidence that the Big Bang ever happened. Dark energy will have erased the proof entirely. But from this terrifying cosmic death, what is the ultimate truth we learn today? From this terrifying cosmic death, what is the ultimate truth we learn today? Here's the part nobody tells you. The universe doesn't owe us an explanation. People say we have all the time in the world to figure out physics. Wrong. Our universe is actually on a clock, and it is ticking down right in front of our eyes. With every red wave, a moment is lost. This is where your intuition completely fails. We are alive in this golden, tiny window, right now, where our eyes can catch the ghosts of these scattered lights. If we were born billions of years earlier, we couldn't properly measure the expansion. The universe was small and uniformly glowing. If we were born trillions of years later, we wouldn't even know dark energy existed, or that the universe was ever big. Let me say that again because it will break your brain. Our existence is perfectly timed at the peak of observation, where our minds evolved just in time to calculate the exact frame of reality trapping us. Light will keep dying on that cosmic treadmill. It is bleeding out of energy because the first law of thermodynamics is violated by an absolute expanding space. Total mass-energy balance is not fixed. Reality is being stretched to its absolute breaking point. Now watch how this trick works. What is the expanding, accelerating universe teaching us? It's not just physics. It's the precious, fleeting nature of information itself. With every gaze, with every deep sky photograph, the universe is slowly disappearing right in front of you. Try this. Go outside tonight, look at a star, then realize something. That galaxy might have already crossed the horizon of reality, and you are trapping the final fragment of its dying present inside your eyes. Our space exists just to remind us of our limits. So inside this paradox, we must cherish the illusion trapped in the physics, where light bleeds its energy into the stretching ocean of time, slowly fading into nothing. The secret? We are the lucky ones. We get to watch the stars before they bleed out entirely. If this video shifted your reality even a millimeter, hit that subscribe button. The universe is darker than you think, but we'll explore every shadow together. I'll see you in the next one.